Let's continue with properties of hydrogen reaction with metal ions and metal oxide. It reduces some of the metal ions in aqueous solution, particularly which are less reactive than hydrogen, and oxides of metal, they are less reactive than iron. Iron can also be reduced into corresponding metals. Hydrogen reacts with salts of platinum, Pd plus 2. It gives platinum solid plus 2 H ions. Same reaction can take place with copper also. H2 plus Cu plus 2 ions will give you copper solid plus 2 H ion. This process is also called hydrometallurgy, which you will be studying in class 12th also. PbO is reduced with hydrogen to give Pb plus water. Copper oxide is reduced by hydrogen to give copper plus water. Fe3O4 is reduced with hydrogen to give Fe plus water. Ferric oxide out of these Fe3O4 is difficult to reduce. PbO and CuO are easily reduced. Next we have hydrogenation of vegetable oils using nickel as a catalyst gives edible fats, vanaspati ghee and margarine. Reaction with organic compounds, it reacts with many organic compounds in presence of catalysts to give useful hydrogenated products of commercial importance. For example, oil is unsaturated, which reacts with hydrogen in presence of nickel as a catalyst. It gives saturated fat, that is vanaspati ghee. Vanaspati ghee is harmful for health because it contains nickel, some amount of nickel, which is carcinogenic substance. So vegetable oils are better for health than vanaspati ghee. Ethene on hydrogenation in the presence of nickel at 473 Kelvin gives ethane. Similarly, ethane reacts with 2 moles of hydrogen in presence of nickel as a catalyst at 473 to give ethane. So here unsaturated compounds are converted into saturated compound by hydrogenation using nickel or platinum as a catalyst. Hydroformylation of olefins yielding aldehydes which further undergo reduction to give alcohols. This is called oxo process. Alkene reacts with water gas, carbon monoxide and hydrogen in presence of catalysts like dicobalt octacarbonyl. It results in the formation of aldehyde RCH2CH2CHO. Aldehydes are further reduced with hydrogen in the presence of nickel as a catalyst to give higher alcohol. Means aldehydes and alcohol contain the same carbon atom, but from alkene it will be higher carbon atoms. Let's take up example. Comment on the reaction of dihydrogen with chlorine, sodium and copper oxide. Hydrogen reacts with chlorine, so hydrogen acts as reducing agent, whereas chlorine acts as oxidizing agent. So chlorine gains electron to form chloride ion, whereas hydrogen loses electron to form H positive ion. An electron pair is shared between hydrogen and chlorine, leading to the formation of covalent bond. But this bond has got 21% ionic character because it is polar covalent bond. Dihydrogen is reduced by sodium to form sodium hydride. Here hydrogen is acting as oxidizing agent, sodium is reducing agent. Sodium loses electron to form sodium Na plus ion, whereas hydrogen gains 1 electron to form H negative ion. This is ionic hydride. Dihydrogen reduces copper oxide to copper, the reaction we have taken. Copper will come out to be in zero oxidation state. Hydrogen itself will get oxidized to water, which is a covalent molecule. Tritium, which is isotope of hydrogen, is obtained by bombardment of lithium-6 It's isotope of lithium with neutron. We get helium-4 and tritium-3 is formed. It has neutron-proton ratio highest, which is equal to 2. It's radioactive, having half-life of 12.33 years. Tritium is separated from helium by absorbing it on metallic uranium as Ut3, which on heating at 300 degrees centigrade gives back tritium. Ortho and parahydrogen, these are isomers or allotropes of hydrogen. Normal hydrogen is a mixture of 75% ortho and 25% para forms. Hydrogen is the lightest element, so in hydrogen molecule, the protons of hydrogen molecule spin. So there are two nucleus. If the protons of both the nuclei spin in the same direction, we call it ortho form, and when they spin in opposite direction, we call it para form. Ortho and para forms are called spin isomers as they differ only in spin of nuclei of the two atoms in the molecule. A decrease in temperature favors the conversion of orthohydrogen into parahydrogen, and absolute zero hydrogen consists of only para form, whereas pure ortho form cannot be obtained. Next topic we are taking atomic and nascent hydrogen. Atomic hydrogen consists of hydrogen in atomic form. It will be obtained by dissociation of hydrogen molecule when under 3.2 kilocalories or 436 kilojoules per mole of energy is supplied. It is obtained by passing molecular hydrogen at 4000 to 5000 degrees centigrade at low pressure of 0.01 mm pressure over tungsten and palladium, or it should be made up of tungsten or platinum. Atomic hydrogen can be prepared by passing the electric discharge through molecular hydrogen at a very low pressure. The half-life of atomic hydrogen is only 0.3 seconds, so recombination of hydrogen atoms to form hydrogen molecule releases 103.2 kilocalories per mole or 436 kilojoules per mole. Thus, liberated can be used for welding purposes, and this is the principle of atomic hydrogen torch. Even oxyhydrogen flame can also be used for welding purposes. Atomic hydrogen is a stronger reducing agent than molecular hydrogen. It reduces carbon dioxide to formaldehyde, ethylene to ethane, alkali metal nitrites, nitrates, cyanides to the metals. It also reduces permanganate and chromates to lower oxidation state and oxygen to hydrogen peroxide. The hydrogen gas generated in C2 means in the reaction mixture itself, is known as nascent or newly born hydrogen. It is also highly reactive because it is under pressure of solution, so its reactivity increases. Nascent hydrogen is more reactive than ordinary hydrogen. An acidified solution of KMnO4 does not undergo reduction with molecular hydrogen, but if we react it with hydrogen produced in the reaction mixture itself, by zinc dust and dilute sulfuric acid, the hydrogen will be able to reduce KMnO4 to MnSO4, that is pink color of KMnO4 changes to colorless. A mixture of zinc and dilute HCl, sodium and absolute alcohol, zinc, copper, copper and water or alcohol, and electrolysis of water are some important source of nascent hydrogen. Remember, the reactivity of nascent hydrogen will depend upon the source from which it is obtained. Next, we take up uses of dihydrogen. Largest single use of dihydrogen is synthesis of ammonia, which is most important for the nitrogenous fertilizer by which we use it in agriculture. These fertilizers we use in agricultural, and the economy of a country depends upon agriculture. That's why it is most important. It is also used in manufacture of nitric acid. Ammonia is used for manufacture of nitric acid, and ammonia in turn is produced by hydrogen. Dihydrogen is used for making vanaspati ghee from vegetable oils, which are large number of they have large number of double bonds. That's why they are polyunsaturated oils like soya bean, cottonseed oil. It is used in manufacture of bulk of organic chemicals, particularly methanol. Carbon monoxide gets reduced by hydrogen in presence of cobalt as a catalyst to give methanol. It's widely used for manufacture of metal hydrides. It is used for preparation of hydrogen chloride, which when dissolved in water we get hydrochloric acid. And metallurgical processes, it is used to reduce heavy metal oxides to metals. Atomic hydrogen and oxyhydrogen torch find use in cutting and welding purposes because temperature is very high, 4000 to 5000 degrees centigrade. It is used as rocket propellant in space research. Dihydrogen is used in fuel cell for generating electrical energy. It does not create pollution and its efficiency is high. And even water formed in fuel cell can be used by astronauts for drinking purposes. And even this water formed can be photoelectrolyzed into hydrogen oxygen pack, which can be reused.